Hello everyone, I am Dr. Nitin Thorat, Assistant Professor, Department of Chemistry, Maharaja Jawahirlal Shinde Mahavidyalaya, Srigonda. Dear students, I have prepared a series of lectures on stereochemistry of disubstituted cyclohexane. This series I have prepared for TY BSc Chemistry student affiliated to Savitribai Phule Pune University, Pune. This chapter is from first semester TY BSc Chemistry, paper 3, Organic Chemistry. I have prepared this series as we know that it is very difficult to you join offline classes in the college. That's why I have prepared a series of 7 lectures on this chapter. Instead of making big video, I have made small videos, so it is very easy to share. In first lecture we will talk about stereochemistry of 1,1-disubstituted cyclohexane. In second lecture we will talk about stereochemistry of cis-1,2-dimethyl cyclohexane. Third lecture, stereochemistry of trans-1,2-dimethyl cyclohexane. Fourth one, stereochemistry of cis-1,3-dimethyl cyclohexane. Fifth one, stereochemistry of trans-1,3-disubstituted cyclohexane. Sixth one, stereochemistry of cis-1,4-dimethyl cyclohexane. And seventh one is stereochemistry of trans-1,4-disubstituted cyclohexane. Instead of showing slideshow, I am showing elaborative notes of the concept of stereochemistry of disubstituted cyclohexane, so that while listening this video you can write your own notes. Let us start with first lecture, that is stereochemistry of 1,1-disubstituted cyclohexane. As we know that 6-member carbon ring called as cyclohexane, and when there are 2 substituents on this ring called as 1,2-disubstituted cyclohexane. There are 4 different type of structural isomer for 1,2-disubstituted cyclohexane. What are these? 1,1-disubstituted cyclohexane, 1,2-disubstituted cyclohexane, 1,3-disubstituted cyclohexane, and 1,4-disubstituted cyclohexane. Let us start with 1,1-disubstituted cyclohexane. So what is meant by 1,1-disubstituted cyclohexane? When both substituents are present on same carbon, such a compound is called as 1,1-disubstituted cyclohexane. There are 12 hydrogen on cyclohexane. Out of that, 6 are equatorial and 6 are axial hydrogen. So these are the equatorial hydrogen, these are the equatorial hydrogen, these are the axial, right? This is the difference between equatorial and axial hydrogen. First question, in case of 1,1-disubstituted cyclohexane, geometrical isomerism is not possible. Why geometrical isomerism not possible in case of 1,1-disubstituted cyclohexane? Because in 1,1-disubstituted cyclohexane, both substituents are present on the same carbon, and due to this, geometrical isomerism is not possible in case of 1,1-disubstituted cyclohexane. Let us talk about optical isomerism. In case of 1,1-disubstituted cyclohexane, 1,1-disubstituted cyclohexane is optically inactive. Why 1,1-disubstituted cyclohexane is optically inactive? 1,1-disubstituted cyclohexane is optically inactive because of plane of symmetry. This is a plane of symmetry passing through C1, C4 carbon. So remember, 1,1-disubstituted cyclohexane is optically inactive because of plane of symmetry passing through C1 and C4 carbon. Another important phenomenon is ring flipping. So what happened? Ring flipping means what? Conversion of one chair into the another chair, called as ring flipping. So what happened in ring flipping? In ring flipping, the group which is axial become equatorial and the group which is equatorial become axial. So remember this difference. During ring flipping, what happened? Axial group becomes equatorial and equatorial groups become axial. So this is useful for to calculation of stability. Let us talk about its conformational isomer. In case of 1,1-disubstituted cyclohexane, two chair conformations are possible. So which is more stable? Let us talk about its relative stability. If x and y is same, means both substituents are same, then these both conformer having same stability. If x and y is same, then both conformer having same stability. If x and y is different, if the substituents are different, then which conformer is more stable is depends upon the size of x and y. If x and y is different, then which conformer is more stable? A is more stable or B is more stable? It depends upon size of x and y. Whether conformer A is more stable or B is more stable, it will be depends upon relative size of x and y. The conformer will be more stable when bulky group occupy at equatorial position. Let us consider this case. If x is bulky, then conformer B is more stable because bulkier group at equatorial position is always more stable. Other hand, if y is bulky, then conformer A is more stable than the B. There is question in previous exam, why 1,1-dimethyl cyclohexane is optically inactive. Here we saw 1,1-disubstituted cyclohexane is optically inactive. 1,1-disubstituted cyclohexane is optically inactive. The reason is plane of symmetry passing through C1, C4 carbon. Now here question is, why 1,1-dimethyl cyclohexane is optically inactive? The answer is absence of asymmetric center. 1,1-dimethyl cyclohexane is optically inactive because of absence of asymmetric center. In case of 1,1-dimethyl cyclohexane, chiral carbon asymmetric center is absent, that's why it is optically inactive. If these two groups are different, then reason is presence of plane of symmetry passing through C1, C4 carbon, but both substituents are same, then reason is absence of asymmetric center, chiral center. So remember, 1,1-dimethyl cyclohexane is optically inactive because of absence of asymmetric center. Thank you.